Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at topologies. We'll be discussing physical and logical topologies, WAN topologies, point-to-point WAN topologies, LAN topologies, half and full duplex communications, and finally looking at access control methods. This episode is part of my series on Introduction to Networks. I'm Kevin here at KevTechify. Let's get this adventure started. First thing we need to talk about is the physical and the logical topology. It's the same network, but it's represented in two different ways. The physical topology. The physical topology is a map of how everything is laid out, where the computers are, where they're located in the room. Computer 1 is located in the front row on the left side. Then how is that wire ran that connects it back into the switch, that connects it into the router, that connects it into the internet. That wire runs down the table, underneath the floor, runs up into the wall, across the ceiling, across the hall, down the hallway, takes a left, runs all the way over there to the switch. Then that switch is then connected into the router by a wire that runs across the room. And so we lay out exactly physically where that is. A logical topology is a representation of how we group them together logically. Meaning, let's put all the computers in a certain network together. We don't necessarily care that one is in rack 2 and the other one's in rack 4 and the third computer is way over in a different room, but they're all on the same network. And conceptually, this is how we view it. Most of the time when we're dealing with networks, and for the rest of this series, we're going to be typically talking about logical topologies, how we group the networks together. And then we can design and process these different networks and get into the requirements. One way of looking at these two different types of topologies is the physical topology is that road map. You will unfold that map, you have a big map, you're looking at it, it lays out your states, it has the cities, it has exactly where the freeways goes, it goes up a little, down a little, it's 50 miles apart and the next city's 100 miles apart, that type of stuff. The logical topology is sort of like, okay, if you want to get from here to the next city, you have to go north by northwest 50 miles and you're going to get there. And so you don't know exactly what you're going to do, but let's just go northwest 50 miles and you're going to get there. And so the physical topology is how actually everything is laid out. The wires, the computers, the roads, the cities, the elevations, all of that. Logical is let's group them together in a simpler way. Something that we can look at and manage together. At northwest, 50 miles, let's put all the computers in one network. Let's represent that by just having one network. There are several WAN topologies out there. There's typically 3 that we talk about. One is the point-to-point. That's probably the most simplest. That's a permanent dedicated network just between 2 devices. A lot of times it's 2 routers. VPNs are point-to-point connections, if you've heard of VPNs. And what that is a connection that's always on, that's always up, always running. And you send data in one end of the connection, it always comes out at the same end. You can think of it as like a piece of pipe. You put water in one end, it's always going to come out the other end. It's not going to leak out some other place, that type of stuff. You put water in one end, it comes out the other. Same thing with a point-to-point. Hub and spoke is taking the point-to-point, but you have one central device and then you have multiple point-to-point locations coming out from there. And a mesh is all the computers in your network have a point-to-point connection between that computer and all the other computers. So all computers are connected with a point-to-point connection to each other. This gets fairly complicated, especially when you have more than a handful of computers. Take 2 computers, you have to have 2 connections, or 1 connection. Take 3 computers, you have to have 3 connections. But all of a sudden, when you have 4 computers, you connect the computers going out the outside, but now you have to cross through the center. and you're up to 6 connections, and then you go to 5 computers, and all of a sudden you've got a lot more, and it exponentially grows. The more computers you add, the more it is. So a lot of times we don't see a full mesh network. A lot of times we see a partial mesh network where we do mesh between the computers that are the critical ones in our network. LAN topologies, we do have several of them that are we see quite a bit. Star topology is probably the main one that we see. The star topology is where you have a switch and you have all these computers plugged in. Now, when we talk about the star topology, that is the logical topology of how they're set out. They're probably not all set out. Take computers all in a room. You have rows of tables, and each row has 4 computers on it. They probably all run the wires down to the floor, underneath the floor, up the wall to the front of the room where the switch is. Logically, they're directly connected into that switch. And so it forms sort of a star around the switch if you would draw it logically. Now, if you drew it physically, how the wires actually ran, it would be all the computers, all the wires run down and up, and it doesn't look like a star. And so that's the difference, another difference between the logical and the physical topologies. Star is the most common one we've seen. Extended star is just taking the star a step further. Basically, you have 2 stars, and let's connect up the switches that are there. And that's what the diagram is showing us, is basically you'd have 2 switches there where the 2 groups of PCs are connecting in, and then those switches would be connected by another cable. And that gives us our extended star. We have 2 more LAN topologies. They're typically not used a lot. Bus topology and the ring topology. Now, they're a lot slower technology, a lot finicky technology. Bus topology is, think about a bus, is it goes from stop to stop to stop. When this token is passed on the bus topology network, wherever the token is, you can send data at that point in time. And then the bus moves on to the next stop, the next computer. That computer then can send data. It stops whether it wants to send data or not, and then it goes on to the next one. But if one of the earlier ones wants to send it, they have to wait till the bus comes back. Wait till the token comes back. Ring topology is kind of the same thing as the bus topology. It passes a token around, but that token goes in a ring. Bus topology, it goes forward to the end, and then it goes backwards to the end, and it just goes back and forth. Ring, that token gets passed around. If you like this episode on topologies and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Now, how this communication happens, it can either happen in half-duplex or full-duplex. There's Simplex, one-way communication. One-way communication would be something like a megaphone, where somebody is yelling and everybody is just hearing it. They're not communicating backwards. They're not communicating back to the person yelling. Communication is just happening in one way. Then we have half-duplex. Half-duplex is you can talk in one direction. The example up here shows us 2 cans in a string, where typically one person can talk in the can, and can go across the string, and you can do that. But if both of you are talking, that means nobody's listening. Think about like a walkie-talkie, where you have to push a button to talk, and then once you push that button, you're broadcasting. But when that button's not pushed, you're transmitting. And so when you're pushing that button, everybody who's not transmitting can hear you at that point in time. But if 2 people are transmitting, nobody's listening at that point in time, so communication isn't happening. And full duplex is like a phone, where you can talk and listen at the same time, right? You have a heated conversation with your friend about whatever's happening, and both of you get really excited, and both of you are talking at each other, and you can listen to each other at the same time and carry on a conversation. That's full duplex. Now, here's another example of what it is. Simplex, Think about your computer and a monitor. The signal being sent from your computer to the monitor, that's simplex. Data is only flowing from the computer to the monitor. It doesn't flow the other way. Now, if you have a special touchscreen monitor or something like that, yeah, data will have to flow back from the monitor to the computer. But we're talking a normal monitor here. It just flows from the computer to the screen. Half-Duplex is one computer can send data at a time. One data can do that. A lot of times a half-duplex connection though can look like full-duplex because sending data happens quickly. And once again, when I'm talking quickly, we're talking milliseconds. And so one computer A could send some data, and a millisecond later, computer B could send some data, A could send some data for a millisecond, and back and forth it goes. And in the end, it looks like it's happening at the same time, but realistically, it's only happening in one direction. In full duplex, those computers can communicate both at this actual same time. It can send and receive bits at the same time. Now, how do we access control? Well, there's two methods here of looking at how we do it. One is a controlled access and one is contention-based. Controlled access is very orderly. We're looking at, let's set up a process where we're going to allow only one person to talk at a time. And by this process, we won't have any problems or collisions on the network. This is underneath here, you can see where it says control access methods. This is token ring or fiber distribution data interface. Token ring, you're passing the token around. When you have that token, you can talk. Otherwise, you're always listening. When you're done talking, you pass that token around. If you want to talk, you have to wait until you get that token. Maybe nobody's talking and that token is just traveling in a circle if you're not a token ring, and you just reach out and grab that token, and you know when you have that token, nobody else is going to talk. And so there's no interference at that point in time. But only one station can transmit at a time. You have to wait. Contention-based is when you have multiple devices and they all want to communicate. They all want to communicate, and sometimes it happens at the same time. And if multiple devices communicate at the same time, it's like when multiple people communicate at the same time. Get a room full of people all trying to get their point across all at the same time, you're just going to get a lot of noise. You're not going to understand any messages coming across. Maybe the closest one or the loudest one you're going to understand, but you're not going to understand everybody. And so you come up with a method that maybe the person that's holding the special little doodad is the person that gets to talk. Or we're going in alphabetical order. Person with the name starting with A, they get to talk for a minute. Then B gets to talk after that and work through that. So you come up with this process. And for computers, there's two methods. It's carrier sense multiple access is a common one, but one is carrier detection, one is carrier access. CSMA CD carrier detection works in this way. If I have data I want to send out on the network, I listen. Is there anything being sent on the network? No, there's not. Okay, I'm going to send my data. And the data gets sent. Okay, I have more data to send. I listen. Anything going out? Nope, I send my data. Okay, I have more data. I'm going to listen. Anything being sent? Nope, I'm going to send it out. But this time, a collision happens. The engineers, they figured out how to detect when two messages are sent at the same time. There's a collision that happens. The engineers figured that out. And when there's this collision happen, the devices, what they do is they say, hey, there's a collision, so our data didn't get through. We have to resend our data. And what we're going to do is we're going to wait a random amount of time. We're going to wait a random amount of time, and hopefully the two devices don't wait the exact same time. Hopefully it's different. One will wait a little bit longer than the other. So the first one will start sending. When the second one tries to send data, it's going to listen to the wire. Is there anything on the wire? Oh, somebody's sending, so I'm going to wait a little bit longer. And hopefully that eliminates the collision for that. And so that's how carrier detection works. Carrier access is a little bit different. Carrier access deals with some delays in there. And so in this example here, we have computer A. It's sending some data. It sends some data. It pauses for a second. It waits for an acknowledgement to come back. After it gets that acknowledgement, the system waits a delay. In the computer, the main one, so B is the main one here, saying, okay, now Is there anybody else that needs to send? Okay, C wants to send. Let's have C send the data. And so they send the data. And B is controlling this access to the network. B could be a laptop that is in an ad hoc network. B could be an access point. Access points control that. And so only one laptop, only one mobile device can talk to an access point at a time. And the access point controls who can talk and when. It was my pleasure to provide you with this wonderful episode on topologies. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. You can get all of these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.